will talk about vehicle-to-vehicle communication today. Why I'm talking about vehicle-to-vehicle communication is because I'm working for around about 4 years on these topics for Volkswagen, and yeah, I think I have some knowledge about this. So when I will start, I will talk about this, and I think I have to give you a short motivation on this. After this, I will introduce some basic concepts, which is really important to understand for the standards. Then I will go through some standards. Afterwards, yeah, some security stuff. In the end, I will talk about what's the challenges actually and what we want to do in the future. Okay, let's start with the motivation. The really basic motivation of vehicle-to-vehicle communication is that we want to avoid any crashes, any accidents, and this is becoming harder and harder for the automotive industry because we got a lot. We solved a lot of problems in the last years, and the problem is that there are some events we cannot predict, or even it is hard to detect with some sensors. So when you have an emergency vehicle driving around with its signals on and such things, we have some really we have accidents which is really not nice actually, and with a normal sensor it is really hard to detect these emergency vehicles because they behave in a strange way. They don't follow some rules which you have in the normal traffic things. This is similar to other things like a red light violation. This is also really hard to detect for a normal vehicle. So, and we think we can solve this problem with communication between cars. You may heard about this technology already, and all these kind of hazards have some things in common. One thing is that they are really local, so we don't have some influences in kilometer away. It's really a local hazard, and so we have short distances we need to overcome with this communication, and this is between vehicles, but we can also communicate between vehicles and infrastructure like roadside units. This is really important with signal lights and such things, but I will not really talk much about infrastructure here. We also think, when you think about these use cases and accidents, you need to be really fast. At least we want to be faster than human in its reaction. So we think we need some communication latencies under 10 milliseconds. It's a guess, actually. Not actually, but this was a guess at the beginning. We also have the problem that we cannot predict who is really interested in these information. Since the traffic is constantly moving, and so the relevance of this hazard can change for every car in some minutes, seconds. It depends on the hazard itself. We got in 2008, I think, we got a who own frequency band for communication in this. So that's more or less what we want to achieve with these communications. So before I can go to the standards, I have to introduce some basic concepts. This is really important to understand this. This makes it really easier. So imagine you have an use case. It's like in the front of this image. You have an emergency brake. when this blue car is braking really hard, so then the white car cannot see this emergency brake, and the emergency brake is for this white car important things when this truck is braking and the distance between the cars is too low, then you have a crash. The problem on this use case is that the white car cannot see this blue car. And that is therefore the whole event has some, how to say, it depends on each car in this line. So if the driver of the truck reacts too late, then even the white car has some problem in the end. So you get the multi-vehicle crash, and that's not a nice thing. When you use communication for this, we believe that we can shorten this reaction time a lot because we can uncouple these events. When the blue car is braking and you can send out a message to the white car, you can increase the reaction of the white car. That's the simple idea behind this. This is also working for another use case. This is called the broken down vehicle. There we have, it's similar to the other things. You have an event in the front of the broken down vehicle, and you want to inform all following cars about this. That's the simple idea behind this. But you have to think about a little bit more about it, how to communicate this information. So the simple solution to it is when this blue car, for example, brakes, then he can detect this emergency brake and send out a message. So the white car can react. That's straightforward. And this kind of communication we call event-based communication. But there's another approach for it, since you can change the detection position. So when you send out with the blue car only status information of the car, for example, how fast it is, how is the acceleration, is the braking activated, and such things, then you send it out in a frequent manner, then you can detect these events in the receiving car. This changed a little bit the rules, but we will see later what it will which influence it will have. Both approaches have some advantages and disadvantages. One disadvantage we can see, one disadvantage of the awareness-based communication, I forget this, sending out this status information is we call it awareness-based communication. And this awareness-based communication has some problems. You can detect that there's maybe a car in front of you and it's standing still somewhere, but you don't know why. It's a car defect, or is there a traffic jam or something else? You can't not. For safety considerations, this is fine, because you know there is something and you can reduce the speed and it's really fine, but maybe you have a different strategy for a different kind of events. For example, when there's a broken down vehicle, yeah, okay, you can pass simply, but if is this vehicle in a traffic jam, you may think, oh no, I will leave this highway. So that's a little bit the disadvantage. But there's several disadvantages or advantages for each type. And when you have this event-based communication, you have simply a message which describes this event. But this event-based communication has a status message about the vehicle, and the problem on this awareness-based is that you have a complex interpretation of these these messages. Things. This is only an indication what may be happened there, but in this event-based communication, you can have this event described, and the interpretation is easy. Okay, and on there's also the advantage on the event-based communication that you only need one message to receive. For this awareness-based communication, you may need a lot of messages before you see what's happening and what is going on. But this event-based communication had the problem that you have to precast, you have to know which use cases you need or you want to cover with this technology. So when you have a use case which you cannot anticipate for the future, then you have the problem that you can't talk about it and you can't detect this in the end. That will be a problem when you have a car for 8 years, 10 years in the field. Then you can, 8 years, 10 years, this car cannot detect this use case or this event. So this is a small problem with this. But when you have this awareness-based communication, then you never talk about use cases in the beginning, and you may develop some use cases afterwards with this data. This is possible, but that's, yeah. So, okay. These basic concepts will be really important for these standards. So, the problem with these standards is we have not one. That's almost the same. So, we have, 3 standards yet. This is one in the US, one in Europe. We have one in Japan. Then we have a lot of activities to vehicle-to-vehicle communication. This is in China. And on this slide, I forgot one country more. Even in South Korea, there's some activity regarding this technology. I will, in this talk, only talk about the US and Europe, since that's more or less this what I do at work. What's important to know about this is that in Europe we have the Car-to-Car Communication Consortium, which is standardization and does a lot of this, and in the US it's CAMP. That's mostly OEMs and some other interested stakeholders. So, but the US standards is focused on awareness-based communication, whereas the Europe is focused on event-based communication. You will see this in the standard in the next. So here's one small slide to see who is involved in the development of these standards in Europe. It's mainly the OEMs, then you have some suppliers, road authorities, research institutions, and such things. Okay. I told you that in Europe we have these event-based communication, and we have the main message is we use these decentralized environmental notification message. That is describing an event that is in position, and an event code is on it, and some extra additional data for some special use cases. It's more or less what's in there. The US has a message, it's called the basic safety message, and this is of course awareness-based message, and yeah, I told you already, this contains some status information about the vehicle. But when you work on this topic, you will have the advantages of both. So even in Europe, we have a message called cooperative awareness message. Of course, it's an awareness-based message. It's really similar to the basic safety message. And yeah, the US, they have a flag field in this basic safety message, which is also more an event-based communication. So after some development, we mixed up these advantages of both approaches, but you will see later that it's a little bit different. I will not talk more about this content of these messages, but you can see on the left and on the right in which standard they are defined, and then you can have a closer look to it. Unfortunately, I think the SAA SAE standards are not public, or you have to buy them, but these ETSI standards you should download it from the internet. It should be possible. Okay, so when we have defined these payloads, what we know, what use cases we want to cover, we have the problem that we have not only these 2 messages or 3 messages, we have a lot of different messages. So we need some kind of message multiplexing. For example, in other messages, bed and map, this is signal phase and timing. This is something related to traffic lights and such things. Okay, in Europe we have some a basic transport protocol, which has an own header. This is similar to UDP, but has no length indicator field or something like this, but has a source port and a destination port. And what's also different to the UDP is that the allocation or the mapping from the port to the application is not done dynamically like a normal computer, but it's defined in a standard. That's all. In the US, we have not such a protocol between it, but there's an implicit convention. This is that you have one element in the beginning of this payload, and there's an enumeration, and you have a switch between the messages. Okay. The problem now is you don't know who to inform you about some traffic events. So at least you have to think about how to route these messages and who could be interested in these messages. Therefore, and for awareness-based communication, the really simple solution and which we use is that we simply broadcast this information. So since we don't know which use cases may happen actually, we use this broadcast approach. We call it single hop broadcast since we don't intend to forward these messages for that's simply all. But when you have an event-based communication, then you know who could be interested in it. And for example, for this broken down vehicle, we have we know that all following cars may be interested in this information, but all these cars which has already passed, they have not any advantage with this information. So you can define a special area maybe and send out a message which can be read or forwarded in these areas so that we can inform all these cars which are in this area you can define. That's the 2 important routing mechanisms we are using. And in Europe we have the protocol. It's called geo-networking. This supports these 2 routing algorithms, but there are some more routing algorithms which is not so important. But what you see is that this geo-networking protocol has 3 headers. The basic header and the common header have some not normal, but have some controlling information about this protocol, and the extended header has some additional data for these protocols, for the algorithms we use to broadcast this information. The separation of the basic header and the common header, I will talk about this later. For the US, they have only one header at this, and this header is really simple. Since they was more focused on the awareness-based communication, they don't need these additional algorithms, so this header is simply a broadcast protocol, and it's really easy. As I already said, the title of the talk said that is based on 802.11p. both standards are based on this. So 802.11 requires a header that is called logical link control and subnetwork access protocol. This is simply also in message multiplexing, and each kind of message has a fixed identifier, and you see these ether types at the top. The P extension of 802.11 is one flag. This is this .11 OCB activated. That means outside the context of BSS, of a basic service set. This simply disables all things which has to do with an access point. So you have no access point discovery, you have no authentication, no association, no simply all things which is with the basic access point things. And there are some other things we don't need in this. So at least we use 802.11 only for broadcast at this point. Yeah, I think this is almost all about these headers, but I want to say something about these frequencies we are using actually. This is the frequency band we use, and this is not fixed to any technology. So actually you can use any technology in these bands, but they have to be related to ITS things. So, and the US and the European is a little bit different in the transmission power you can use, but that's all. Okay, this is basically the standard, this is the concepts of the standards. In the detail there, you have to look in these standards. How we use security in vehicle-to-vehicle communication. We have some requirements. This is things we have to deal with safety-related things and accidents. We want to have the possibility to authenticate the sensors a little bit. So not anyone should send any messages. This is a little bit dangerous in our view. But we all want to protect the privacy of the drivers, and we have some standard attacks we don't want to have, so replay attacks and such things. But unfortunately, I don't know so much at the US of the US standard to this, so I will only talk of the European standard. Yeah. The problem now is that we have to think about security in the case that we want to have some security. Don't want to change messages from anyone. So the problem is now that we have to put some signature at the end of the in the security payload, but when you use it. Sorry. We cannot use IES or something like this because we have to use one shared secret, and shared secret about sharing between several million cars maybe, it's not a secret. So we have to use, sorry, I forgot the name. We have to use something like, sorry. We have to use things like IES or things like elliptic curves or something like this. But the problem there is you have a private and a private key and a public key, and this is coupled together. When you have one private key, there's when you read an identifier with a public key, or you can decrypt it with a public key, then you have the problem that there's only one private key to it, and then this is an identifier that is unique. So privacy is a problem with this approach, but therefore we have a pseudonym certificate and long-term certificates in each card. To understand how that works, we have to look on the public key infrastructure. Each car is provided with a long-term certificate, and this long-term CA is direct on the. You get this certificate at the production time for each car. So each car has its own long-term certificate. Things we want to have this technology to work with different manufactured with cars from different manufacturers. We need a root CR somehow because each manufacturer will have its own long-term certificate authority, and we have also a feature that is called cross-certification. Things we need different root CRs because every country in Europe maybe will have its own root CRs. So that's a political decision. But you are not allowed to use these long-term certificate for communication with other cars. For the communication with other cars, you use these pseudonym certificates, and one feature about this is that the car can change this certificate as it wants. So, and you use these long-term certificate only for authentication for the pseudonym certificate authority. This, of course, knows about the root CR, so that you don't have to know about these long-term certificates, CRs, long-term certificate authorities. So, and you can get a lot of pseudonym certificates. Therefore, you have some kind of privacy because you have a lot of pseudonyms. Yeah. How many certificates you have? The thing is, you have more than 20 certificates in parallel for around about 1 week. And you have some rules when you have to change these certificates. That's at the engine start, and you have to change these certificates every 10 to 30 minutes. But all these things are actually under discussion. That's not standardized yet, and it will be standardized in the basic standard profile of the Car-to-Car Communication Consortium for the European. Yeah, maybe it's not fixed actually. Okay, but what means a pseudonym change? As you see on the right is that we have the security is not a vertical layer in our stack, it's a horizontal layer, because you have to change every identifier you have. It also includes the MAC address you use actually. That also means you have any identifier in the applications and such things. So I would personally say that the security should be like this in the stack image. But we have another problem with pseudo-identifiers. When you think about communication, awareness-based communication here, we have something, we need the vehicle dimensions to work with this. So, and the vehicle dimension, it's a small problem. When you have a Golf from Volkswagen or a normal BMW or something like this, that's all okay. But when you drive a Lamborghini, that's a really unique vehicle dimension. It's really low, but it's wide and long, so that's more or less unique. When you drive around with a Lamborghini, then you have the problem that this is also an identifier, since you are alone on the street. All the other cars around you will not look like a Lamborghini. So therefore, we reduce the accuracy. We use the accuracy of these values. So that's on 10 centimeters. Yeah. But you have to care about these things. Okay. The long-term certificates are valid for several years, but they have at one point you have to exchange these long-term certificates. That's even the same with the roots certificates. But as you see already, we use elliptic curves for it, and these standards are, we talk a long time about the standards, and we actually use the NIST curves in the standards, but yeah, there's a discussion with the Bundesamt für Sicherheit in der Informationstechnik of Germany, and they want to change this a little bit. And one change is that they want to have the brain pool curves. For us, it doesn't matter. We need an ECDSA 256 curve, since our hardware acceleration actually works only with these curves, but it's not on the curve. We don't depend on the curve. And actually, we use these elliptic curves for every certificate in the standards, and they want to change it also, but yeah, that will be also changed, since we only need it for the communication between cars. One thing about this hardware acceleration is this is really important for us, since we anticipate that we have, in the worst case, around about 700 to 800 messages per second, and then you get a problem with validation of these certificates. So we need a really hardware acceleration at this point. But this is worst case calculation, so in the beginning we will not have this problem. Okay, what else? Yeah, we need to think about more things. At the moment we have communication and we can exchange data, but the problem is the interpretation of this data. We have to define really strange things, or things you don't expect at the beginning. When you have a position which you share with all the cars around, as an advanced driver's assistance system developer, you have the problem, where's the reference position? Is it in the center of the car? Is it on the front bumper, or is it on the rear bumper, this reference position? Because that means maybe up to 2 meters different. That's, it's about such things we have to talk with all the other OEMs. And so we will standardize this in a standard profile, and the triggering conditions is about when you should send out an addendum message to indicate that there's an event somewhere. This is also not so easy to define. In the United States, we will have minimum performance requirements. Yeah. And then there are some challenges, also things. When we talk about safety, you want to know how the system works at the boundaries, on the system boundaries. So what happens when the channel is full? When you can't send any more messages? Or what happens, or how far is the communication range? Which influences the environmental of these cars? So which influences in which on this communication technology and such things. And even we have to think about coexistence with tolling gates in France, for example. Yeah. Then also I want to introduce that the Technical University in Prague is actually working on a patch for the Linux kernel to support these OCBs mode of IEEE 802.11. Yeah, I hope it's not finished yet, but I hope this becomes finished in the beginning of next year. You will find this on this address. When you are interested in the implementation of these upper layers, then you can find it at these Vannetzer on GitHub. I think there's some more implementation, but this is actually something we also use. Yeah. What in the future? for the future, you have to know a little bit about driver assistance systems. When you think as an engineer about these driver assistance systems, and then you have a control loop, then with sensors at the beginning, with many sensors at the beginning, since these data are not so easy to interpret, so we have like a fusion to generate one world view for this car. Then you have an interpretation and evaluation, and then you get some plan to what you want to do in the traffic, and then you need a controlling unit which controls all your actuating things, which affects the real world, and then you can again measure the new things you see. The standards, or normally we refer vehicle-to-vehicle communication as a sensor. Things you can provide a lot of information to these driver assistance systems. But since you send out also information, it's a kind of actuating element. So vehicle-to-vehicle communication is not only a sensor. And this is something, the right side is something we will do a lot in the future. But come back to the left side first. Actually, we send out with this awareness-based communication a lot of status information from one vehicle, but we also add some information about other vehicles. So when you see with your radar or with a sensor a car, for example, this car behind this building, then you can send out these measurements or this distance to this car, also with, from the red cars. And then maybe the blue car will have some advantages to know about this car on the right side. Yeah, this is actually, and the second idea is that we can exchange the planned trajectories of cars. So when you precast these, your plan for several seconds, 5 seconds to 10 seconds maybe, and you send it out, it will improve the your assumptions about how the environment will evolve in the next seconds, and this is really a nice information for planning some maneuvers on the street. And maybe in the end we also are able to cooperate with these things to plan maneuvers with different cars together to cooperate. So that's the ideas we have in the futures, but we are actually in the concept phase of this. So yeah, for me, I'm ready now, finished now. So do you have any questions?
The first 2 questions go to the internet.
Yes, thank you. Instead of sending single events, why not broadcasting the standardized set of sensor data so every car can calculate what is relevant to them? This would maybe be more future-proof in terms of autonomous driving.
Yeah, that's totally right. This is more this awareness-based communication, which I've talked about. Yeah, that's something we want to do actually, but we will not send out the normal sensor data. We will more send out distances between cars and something like this. But yeah, this is planned actually. So,
next question from the internet.
Yes, thank you. How much would a system be affected when the root CA, the private key of a root CA is exposed, like we have seen from Sony, Lenovo, etc.?
Yeah, this is a problem actually, which have to cover. But you saw already that we have this cross certification, and when you exploit this, maybe you can solve this problem. When you assume that you sign with different root CRs one long-term certificate, then it's not so important when one root CR is not trust. You cannot trust one root CR anymore. Then you switch to the second root CR. So that's maybe that's a solution to it.
Okay, next question over here.
Okay, I'd like to thank you for your talk. I have seen that you are monitoring also other activities in this area. First, I want to make you aware that there is one activity by Intel, BMW, and some British university, I can't remember, which is doing something comparable but competing, which is, yeah, okay. I don't want to go into too much details.
Okay.
I want to make aware of this.
Do you
and
have
second, do you think what's about availability? I know that Volkswagen is strongly behind the car-to-car concept, but I know that other car makers are going more to a server-based communication, so that cars are not really communicating to each other, but via servers, via back-end servers. And I know some other things behind that.
Yeah, this is right. You have different possibilities to solve this problem. So in the end, you will have some kind of vehicle-to-vehicle communication, but it's not so clear in the end how you will solve this problem. So you can use Wi-Fi, like this, or you can use backend related communication. The problem with backends actually is that you need coverage with your coverage with your mobile devices. So if you are in a tunnel or something, you don't have any more vehicle-to-vehicle communication. This Wi-Fi-based solution has coverage in this case, and you have maybe some trouble with the latencies. This will become less and less a problem since the technology will become better, but yeah, there are some other issues with backend-based communication.
Okay, next question over there.
Hey, I got a question regarding the concept. When I buy a car, I receive a unit that is able to send out messages that are cryptographically signed or whatever. How do I keep people from just using that to perform denial of service attacks on the Autobahn?
It's not possible. You can't denial of services attacks. You can't prevent things, but it is always the same. So when you want to make a DDoS attack on this technology, you can simply by disturbing the frequencies we are using. You can't prevent it. The trick is to detect these. So we need some measures to detect these DDoS attacks, and then we have to stop the car or something like this. We need some backup solutions for how to react with the car.
Okay, thank you.
Okay, next question over there.
Hey, thanks for the talk. It was really interesting overview, I guess. I have a question about the pseudonymous certificates. So I understand that this takes away the immediate danger, or tries to take away the immediate danger of exposing your location profile to the cars, or the location history to the cars in your immediate vicinity.
Mm-hmm.
But you can still build a complete location history for some car by just collecting all the data, because the root CA clearly knows what pseudonymous certificate belongs to which car. So, or are there something like blind signatures in place? And there's another problem, I think. So how do you handle pseudonymous certificate switch? Because if you're going somewhere and you keep receiving messages from certificate 1, and at one point you just start receiving messages from certificate 2, that you know that certificate 1 is now certificate 2.
The second one is some problem for the applications or for the driver systems. this is, you can overcome this because you know that a vehicle cannot jump. So when
I mean, you can clearly tell that that is the same vehicle, so you lose the privacy protection of that pseudonymous certificate step. Or am I wrong?
yeah, you cannot use anymore this identifier by the certificate. That's right. But this car is not jumping around, so the car is driving a straight line. And when you see that there's a pseudonym is vanished and there's a new at the same point and going the same line, you know, oh, from the physics, oh, it should be the same car.
Yeah, that's exactly what I'm trying to say. So
Yeah.
why even do pseudonymous certificates if you can still completely track that one car?
Yeah, that's the other question. Yeah, that's the first question. I was referring to the second question actually. And the first question, yeah, that's the problem now is yes, it's possible. But not the root CA is knowing about this because the root CA only signs these certificates of the ATCA and the pseudonym CA. But the problem is with this that other technologies are also possible to use for the same reason. So you have an ID on your license plate driving around all the time. So when you use a camera, it's much easier to do the same thing.
Yeah, but I can change the license plate.
Even when you change the license.
Yeah.
Yeah.
Sorry.
By now it's kind of time to remind everyone that a question is a short sentence ending with a question mark. And next question over there, please.
Yeah, at first, thank you for your talk. And my question is, who is running the root CAs? Is it the country, or is it a company running this, or is it an independent authority like the Car-to-Car Communication Consortium?
It depends. It's a political decision in the end. I think for infrastructure in Germany, for example, it's running by the government or some institute of the government, of course. Since they wanted to have this, it's a political decision, but anyone can in the end. And you have to cross-sign all these root CAs. That's the political decision. I can't say much about this, actually.
Okay.
We will see.
Yes.
Okay, next two questions for the internet. No questions anymore for the internet? Okay, fine. Over there then.
If you sign locally in the car, the pseudonymous signature key material is stored on the car or generated on the car. If you think about car use times or that cars are in the field for 10 or 12 or 15 years, how do you guarantee that the security of those security chips is not compromised?
Yeah, that's hard. But we will exchange these certificates and these chips at the service, at the car dealer. What's happened when these algorithms are not safe anymore is that we should exchange this hardware at the car dealers at the service. Yeah.
Yes. Yes, some follow-up question to that. So if I'm an attacker, I will not go to the service point, but just buy a car and then 5 or 10 years later use that car to send fake messages. That would be my attack scenario.
Yeah, then you, we actually work on security measurements inside the car, so it's not so easy to exchange any parts and introduce any data on the CAN in the end. Actually, it is possible at the moment, but there will be some measurements against these attacks.
Okay, next question over there.
Okay. How do you, I understand you're using some kind of private key, public key encryption or authentication. So you said also you generate 20 pseudonym certificates per week.
Yeah.
How do you transfer those public keys to all the cars from the millions cars you have on the street?
Okay. I forget to mention that the security headers I add there in sorry, it's a little bit. So the security, you provide these certificates with every message in the worst case. So normally we have some measurements to reduce it, but when you send out this message, you also add the certificate at the end of the message.
Okay, so I've signed my own stuff.
This is the third certificate. Sorry. This one. Yeah. Oh. So you don't sign your pseudonym certificates. You get these pseudonym certificates from the pseudonym certificate authority.
Yeah, but if I send out my messages and I send out the public key in this, I've sent out my message and send out the public key as well, so I can send anything.
Why? You have the private key is in your car. You can't sign this message. As you sign this message with the private key. It's a signature.
Yeah,
it's
with
not
the private key, but the public key must be known to the receiver.
Yeah, you add this public key at the end of your message, and this is all. This public key is signed by the pseudonym certificate, and you need to know the whole chain, of course, and you can also send out these. At the end, you need to know about the root CR, root certificates in your car. This is something we have to put in the car at the beginning, and maybe to add later. But when you know this, you can prove all these the whole chain.
Okay.
Next question over there.
So when an attacker comes in a situation to be able to sign messages with fake data, is it possible to DDoS other cars by sending out messages that trigger emergency brakes, for example, in other cars? And can't this trigger more accidents in the end? So for cars that are not involved in the system?
Yeah, when you have this possibility, of course, you can send out these messages and trigger some events we don't want to have, but then we have some additional sensors. So we don't rely only on vehicle-to-vehicle communication. We also use all these other sensors, and you get in a problem that you invalidate some logic in the car. So you can detect such things, and then you will simply don't listen to these messages anymore.
Sorry, when I simulate the car at all, so if I just take the hardware that signs the messages and put it on a ECU that I totally control, then the messages can't be distinguished between real and fake messages?
You will be, when I have a driver assistance system, you don't rely only on vehicle-to-vehicle communication. You will not do. It's the same with a radar. You don't only rely on these radar. So you use a lot of sensors, and you have a sensor set. And when your sensor set has some logical things which is not logical, then you can detect it, and then you will stop the car or something like this, or you will disable these features and inform the driver. This is the only solution to it. But you can detect it.
Next question over here.
Can you say what is the average length of CAM and DEM messages, and what format and what length has the certificate? So will you use the WAV format from the US or an own developed ETSI format?
We have the own developed ETSI format. The length that's a hard question. Things we can leave out some parts of the messages depending on the sending frequency and such things. So we have around about 270 in the mean. 270 in the mean, 300 bytes at the mean. But
for CAM or for
CAM? For denim, it's a little bit larger, but it's really hard. It depends on your use case.
And the ratio between plain text and security information? So certificate length and signatures?
50%. 50%. Security is really large at this point. So that's the reason why we use elliptic curves. It's some smaller certificates.
Next question over there.
Yeah, thank you. One question is it planned that the certificates can be revoked? And if so, how does the revocation information get into the cars?
Sorry, can you repeat the second?
How do the revocation information get into the cars? Will there be some kind of CRLs or OCSP services or whatever?
Revocation is not defined yet because you have to, the thing is, you don't need to bring the revocation in the car with this public key infrastructure because you have to live 1 week with the problem. Then you need new certificates for the pseudonym certificates. So you only need the revocation at the moment the pseudonym CRs. The problem is that when you never know which certificates are used, since you have no identifier, you have to detect this. That's the problem actually.
But as far as I see, the typical application of car-to-car communication is just cases when your sensors actually can't help anything because you don't see the car in front of the long vehicle that is just braking.
Yeah, that we try to change this with one of these future aspects. So when you have a car in front of you which you see, which action, then you can have some these measurements of other cars and you can validate it. So this leads to a situation where an attacker have to attack all these cars around you to make a logical data validation, so that the validation of the data is somehow will happen right. So that's one thing we like to do about this, and but it's still a problem. So it's the reason. But we assume that you use these data for planning, and you can use this data. The emergency brake light is maybe really a problem at this point. But we try to, for advanced driver assistance systems, we try to use this data for planning, and then when you see the plan is not working out, you need a fallback somehow. It's always about fallbacks.
Okay, thank you.
At least one more question over there.
Have you thought about the following problem? I mean, you have a lot of cars in the world, and every car has a lot of these pseudonym certificates. So and as an attacker who wants to spoof messages, you just need one valid pseudonym certificate to do a lot of harm. Shouldn't it be relatively easy to, I don't know, spend some money on a cluster and produce a lot of private keys? Since there are so many pseudonym certificates for so many cars, shouldn't it be maybe relatively easy to get just one valid pseudonym certificate to do some harm?
You have a validation. You have a time restriction of these pseudonym certificates. So when you have this, you have it for 1 week at the end, and you have to live with this problem, but you have this not worldwide, you have it in Europe or in the US, but it's possible.
Okay. So the certificate, the lifetime
Can we
is
cut this
1
short?
week. Okay.
If the person over there can compress the question in less than 20 seconds, we may be able to do that as a last question.
Yeah. Okay, thanks. I just want to ask, we see every year breaking security concepts on this conference, so how are you securing your model with now in the standard defining ECDSA 256 and saying, we have hardware acceleration for this, with seeing that car is even a long-term product?
When this happens, you have to find solutions and you have to exchange the hardware.
But wouldn't we change it by...
Okay, we're out of time.
Sorry?
Thank you all very much. We're out of time.